Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope everyone is doing all right out there. I don't know what lesson this is. This might be Unit 5, Lesson 10. I don't remember. It's Friday at 5 o'clock. I want to go home, but before I do, I got to finish this lesson. So let's talk about our goals. Our first goal is to review graphing lines in slope-intercept form. Our second goal is to review rules for inequalities. Our third goal is to introduce rules for graphing linear inequalities. And our fourth goal is to compare dashed lines versus solid lines. So let's go ahead and jump into our first goal. I'd like to review slope rules with you. Remember, slope is rise over run. A positive over a positive means I rise up and I run to the right. A positive over a negative means I rise up and run to the left. A negative over a positive means I rise down and run to the right. And a negative over a negative means I rise down and run to the left. I also want to talk about negative signs and fractions. If I have a negative in front of a fraction, I can put the negative with the numerator, or I can put the negative with the denominator. Can't put it in both because you change the sign. All right, and then here's an example of slope-intercept form. Y equals mx plus b. Remember, m is a fancy way to say slope, and b is our y-intercept. We begin on the y-axis, and we move to the next point using slope rules. I have an example that I'd like to work through real quick to help you remember how to graph. And let me find a marker. Hopefully this one works. All right, so using this template, I know that my b value is 4. So I begin at 4. And I'm going to put the negative with the numerator. I'm going to do this guy because I have a negative out in front. So my slope is negative 2 over 3. So I know when I begin at 4 on the y-axis, I'm going to move down 2. And I'm going to go to the right 3 because I have a negative over a positive. There you are, right there. All right, here we go. So let's find 4 on the y-axis. There you are. From here, I go down 2, 1, 2, and I go to the right 3, 1, 2, 3. I'm going to go a little bit further over, and then I connect the dots. And I just graph my line. So that finishes the first goal here. I'm going to go ahead and erase this and set up the next step. So I'll be back. I'm back. All right, so let's go on to our second goal here. And I'd like to review rules for inequalities. And these are one variable inequalities. I should have clarified that. But once we see a few of these problems, I think you'll remember what we did before. So we had a table. And if I had this symbol or this symbol, I shaded to the left. Look at how I spelled the word left. And if I had this symbol or this symbol, I shaded to the right. Now, if I have this symbol or this symbol, I have an open circle. And if I have this symbol or this symbol, I have a closed circle. This is very important. Open circles are not part of the solution. You get a false statement at the open circle. Closed circles are part of the solution. They're in bounds. You get a true statement at the closed circle. And let's remember a couple things here. When I say X, that's the shading. The shading is the solution, and we are describing position, right? So this means to me the shading is right of 4, open circle. So if I was to graph this, it would look like this. An open circle at 4, and I shade to the right. Remember doing that? Here I have negative 2 is right of the shading. But I don't know how to graph that, so I'm going to describe the positions differently. If negative 2 is right of the shading, then that means that the shading is left of negative 2. The shading is left of, look how I wrote left of negative 2, closed circle. So I draw a line, put a negative 2, close the circle off, and I shade to the left. Any value I pick out of here, like negative 5, that's on the left of negative 2. Negative 5 is left of negative 2, that's true. Or negative 2 is right at negative 5, that works. Here, if I pick a value like 10, 10 is on the right of 4, that's true. So again, the shading is the solution, and if I was to put negative 2 in this, and this is left of or equal to, right? So negative 2 is left, or negative 2 is right of or equal to negative 2. It's true because I have the equal to. However, if I put the 4 in here, 4 is right of 4, that's false. 4 is, it would have to be 4 is right of or equal to make it true. So since there's no line, this is out of bounds, and that value makes this false. That's very important. So what we're going to see here is we have a one-dimension version of graphing inequalities. That's what we've done prior. What we're going to do next is we're going to combine two-dimensional graphing with one-dimensional inequality rules. And we're going to know how to shade when we graph on something that looks like this. Now think about the lesson that I gave prior. What did it mean to be on the line that represented $40, spending $40? What did it mean to be above the line when you spent 40 bucks? What did it mean to be below the line? It's all going to start to tie together here. So let me go ahead and I'm going to erase everything and I'll be back. Oh, hungry. I'm back for a third time. So I'm looking at the goals here and I realized that I didn't articulate the third goal well enough. Introduce rules for graphing linear inequalities and graph them. We want to graph them today. We want to be able to graph them. So let's go ahead and look at our third goal. Hey, guess what? Our slope rules are the same. We already know how to do that. And guess what else? Our negative signs and fraction rules. They're the same. Smiley face. Now, instead of shading to the left and shading to the right, lines, you can be above a line or below a line. Look how I wrote the word below. Shade below if you have this symbol or this symbol. Shade above if you have this symbol or this symbol. We're going to use a dashed line if I have this symbol or this symbol. And I'm going to use a solid line if I have this symbol or this symbol. Now, the solid line and the dashed line behave just like open circle and closed circle. Try and think who is who. Who would match up to a solid line? Who would match up to the dashed line? All right, look. Steps to graph in slope-intercept form. Same. We just need to pay attention to which side of the line we shade and if the line is solid or dashed. We're just adding a couple more things to something we already can do. So it's not too difficult here. And you know, I want to add one more thing. The solution is the shading. I really want to reinforce that moving forward. The solution is the shading. That's so important. All right. Okay, so let's go ahead and graph this. I begin at 4, so B is 4. I'm going to put the negative with the 2, so M equals negative 2 over 3. So I rise down and I run 3. My line, I shade above and it's dashed. So I know everything I need to know to graph this. So I begin at 4, 1, 2, 3, 4. I rise down 2, I run right 3, 1, 2, 1, 2, 3. My line is dashed, so it's going to look like this. And I shade above. This is all that I need you to do for this lesson. That is it. What I just did, we added 2 extra steps to something we already know how to do. Now, I'm going to include the 4th goal in this. Okay? And let me pick a couple points to look at here. So, remember the shading is the solution. So, for example, if I was to plug in this point, which is above the line, and its ordered pair is 0, 5, and I picked it strategically because I have a fraction here. If I plug in a 0 for x and a 5 for y, I get 5 is greater than negative 2 over 3 times 0 plus 4. Guess what negative 2 over 3 times 0 does? It cancels out and goes away. And I'm left with the following statement. Is 5 right of 4? That's true. And it's true because it's in the shading. I'm going to plug in now 0, 4. So again, I'm picking a point with an x value of 0, so I make that go away. You can be strategic like that. I could have picked other points, but you know, I'm playing chess here. I don't want to work harder than I need to. So here I have 4 is greater or right of or above negative 2 over 3 times 0 plus 4. Again, that goes away. But 4 is not right of 4. This is false. And so dashed lines is a boundary where the solution does not exist. However, if it was a solid line, because I have or equal to, this statement now becomes true. So if you have a solid line, solutions are on there. If you have a dashed line, solutions are not. Like on a football field, the line is out of bounds, not part of the playing field. On a soccer field, the line is inbounds, part of the playing field. So hopefully this lesson is good enough to get us to be able to graph inequalities in slope-intercept form. Again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.